Welcome back, everybody. This is AP Chemistry, Unit 8 and Section 3, taking a look at within the pH scale and pOH scale and all those fun things we've been doing. We also have this scenario where we get salts that are being affecting our pH and pOH. The acid and base properties of salts is our theme. So salts of any kind, we always think of like salt, like table salt being sodium chloride, but salts are by definition anything that's going to be an ionic compound that's a metal with a non-metal. That's a combination of those things. And there's three types of salts that are going to be producing a particular pH, and we're going to be looking at those in turn. Okay, salts that are going to be consisting of the cations would have strong bases, and anions that have the strong acids. Those are the ones that are going to be producing from the neutral solutions. So let's take a look at what I mean by that when we're making, or why that would be. If I were to mix together these particular salts, and I was going to mix it with produce a salt from a strong acid like hydrochloric, and we get a strong base like sodium hydroxide, that's going to be forming sodium chloride and water. Okay, I'll just leave it as HOH. So here's an example of a salt that's going to be produced. There is no pH being produced because I would find the equal number of hydrogen ions is going to balance my hydroxide. So there's no pH that's going to be produced from that particular reaction. All right. So if I was just going to be taking a look then at salts being producing the neutral solutions, I would see that these ions would have no effect on the hydrogen concentration within the water. Okay. And the reason this happened with this is I would see that my hydrochloric acid would dissociate into my hydrogen and my chlorides, and my sodium hydroxide would dissociate into my sodiums and my hydroxides, and these two would match up. And these two would match up. So it's a very simple example with that. This would be neutral in solution, and I would get a first column with a 17th column that would produce a neutral solution with it. Okay, they would have no effect on the hydrogen ions in the water because that's just going to be neutralizing out. Okay, there's another type of salt that's going to be producing the pH in here. These would be containing anions that are conjugate bases of the weak acid. So I would see that my example from this particular one, I would see my sodium acetate. Okay, here's my sodium, here's my acetate. That's going to be producing my hydrogen ions and forming my acetate. Okay, so that's the two types of products I'm going to be getting off of this. Now, if I were to take my acetate, then C2H3O2, and that's going to be immersed in the water, well, essentially what's going to happen is my water is going to attach then, or I should maybe flip it around and say that my acetate is going to suck up some of the hydrogen ions. Okay, and so when I do that, I'm going to get my acetic acid, C2H3O2, and it's going to be giving me my hydroxides. Okay, if I was going to look up this value, again, this is going to be set up just like an equilibrium problem like we've been doing. So here's my 0.100 molar solution. Now remember, this was my sodium acetate. Now the acetate would then suck up the hydroxide. So my concentration is going to be losing some in this process. And here is my X, and my X, we don't worry about the water in this case. It's just providing those hydrogen ions. I look up my value, and I see that my Kb value for my acetate is going to be 5.6 times 10 to the negative 10th. That's going to equal x squared over 0.100 minus x. So my x value ends up being 7.4 times 10 to the negative 6th. Now remember, that's going to be my hydroxide because I was using my Kb value here. Okay, so pOH is going to be the negative log of my 7.4 times 10 to the negative 6. And so my pOH ends up being 5.13. My pH then is 8.87. Okay, so I just kind of basically find it that way. Now, to find my Kb, there's a couple ways to find that Kb value. Okay, I could look that up. Otherwise, remember, my Ka times my Kb is going to be 1 times 10 to the negative 14. Okay, and so I could also look up the value of my acetic acid. Okay, so this is my acetic acid right here. That ends up being 1.8 times 10 to the negative 5. Okay, that times my Kb equals my 1 times 10 to the negative 14. And so my Kb then was a 5.6 times 10 to the negative 10. And I'm only pointing that out because if you aren't given that value or don't know it, you might have to solve for it. Okay, so just kind of keep your wits about you. We know how to solve for those things from the previous sections. Okay, now we also have one last type of salt that's going to be affecting, we could find out, is salts that will produce an acidic solution. Okay, so we're going to see we have ammonium chloride is going to break down into ammonium and my chloride. Okay, now this is going to be a weak base in here, and so I take a look at this. Here's my acid. Here's going to be my conjugate acid because it's going to be donating back, and here's my conjugate base. Okay, so I would say then that this is my 0.100 because it's my concentration minus X. Here's X, here's X. And so once again, I would just look up these values. My Ka value for ammonium is from the chart is 5.6 times 10 to the negative 10. And that's going to equal x squared over 0.1 minus x. My x ends up being 7.5 times 10 to the negative 6. Now, keep in mind, that was a Ka value. So this is, in fact, going to be my pH, and that's going to be a negative log of 7.5 times 10 to the negative 6. My pH ends up being 5.13. Okay, so what we were doing here is we were taking my ammonium. So my ammonium is going to dissociate into my hydrogen ion and my ammonia. Okay, and so basically just plug those in there. This was my 0.5 or sorry, this is my 0.1, and that's my x, and that's my x. So that's all I was doing when I was solving for those types of problems. Okay, now let's take a look at a couple examples. And let's see what we can do finding the pH within the sodium fluoride. Okay, now let's list my major species in this. When I'm doing this dissociation, I'm going to be creating sodium ions. Okay, I'm going to be forming my fluoride ions, and essentially what's going to happen is my fluoride is going to absorb up some of the hydrogen ions from my water. So that's going to be producing my hydrofluoric. Sodium is going to be just kind of good for nothing, just floating around in there. And so my fluoride is going to interact with my water, and that's going to be making hydrofluoric acid and producing some hydroxides. Okay, so I've got my concentration is a 0.3. And it's going to be losing a certain amount. There's X and X. And so I'll be taking a look, and the question is, how do I know what my values are? Well, I take a look, and I see that my Ka value for hydrofluoric is going to be, I just looked that one up, is 7.2 times 10 to the negative 4. Okay, that times my Kb would equal 1 times 10 to the negative 14. So my Kb for this equation is going to be a 1.4 times 10 to the negative 11. Okay, now I want to take a look and plug that in. So my Kb was 1.4 times 10 to the negative 11. That's going to equal x squared over my concentration for this guy. And that was a 0.3 minus x. Okay, so x would end up in this case being 2.0 times 10 to the negative 6. And remember, this is a Kb value. And so I would find my pOH from that. My pOH is the negative log of this, 2 times 10 to the negative 6. And so my pOH ends up being 5.69, making my pH then 8.81. Okay, again, I subtract that from 14, my pOH from 14 to get my pH. Okay, so pretty straightforward with those. Just kind of keep track of those different things. What I did is I solved for my hydrofluoric first, and then I took a look and plugged that in. And the reason I did that is because I knew my Ka value for it. Okay, then I could find my Kb and plug that in to solve for my concentration for my sodium fluoride. Okay, now next step with this. Only have a couple more to go with this one. Let's take a look at a sodium nitrate solution. Okay, a couple of the things that we're going to be seeing along the way. If I'm looking at this is going to dissociate, and when it dissociates, remember what's going to be happening here. Okay, my nitrate solution is going to be an NO3 with a -1, and that's going to be interacting with my water, and that's going to make my nitric acid. Let's see, NO2 plus OH. Okay. And so this is going to be gaining within there. I'm just realizing that should have been sodium nitrite with that. So it's an NO2 for my species, NO2 a negative. Let's see, I'm going to have my sodium. That's going to be in there. And my NO2 is going to end up forming my nitrous acid. Okay, so that's how I got all these things in there, and this should just be a 2 in there, so that's not a problem. Now, if I look this up, my Ka value for my nitrous acid ends up being 4.4 times 10 to the -4. That times my Kb is going to give me my 1 times 10 to the -14. And so my Kb for this equation is 2.5 times 10 to the -11. Okay, that's for this component right here. Now let's go ahead and use my Kb is going to be 2.5 times 10 to the -11. That's going to equal x squared over 0.500 minus x. And so my x ends up being 3.5 times 10 to the -6. Now remember, that's a Kb value. So my pOH, if I just plug that in, my pOH ends up being 5.45, and my pH then ends up being 8.55. Okay, so again, what do? I take a look at the conjugates of these and then solve them back. Okay, pretty straightforward with them. We don't have any major issues with that. Just take a look at what happens. Remember that this will lose the sodium, dissociate, and then bring in, and I do apologize for that, should have been an NaNO2 instead of an NaNO3. Okay, now let's take a look at one more set in here. Taking a look at some concentrations, and I'm going to be splitting this up. Now, this one's a little bit trickier because we have a whole bunch of things going on. Okay, and so we've got to track them along the way. I have my C2H5NH3Cl. That's going to be producing the C2H5NH3 plus, and my chloride's going to be coming off. Okay, now if I then let's take a look at what happens with this guy. My C2H5NH3 plus is then going to be absorbing losing one of the hydrogens, and so that's going to become C2H5NH2 and generating the hydrogen off of there. Okay, so this is going to decay to get rid of that ion. Okay, so it's this one is the 0.3. It's going to be losing a certain amount, gaining and gaining, and so then I would see that my Ka value, and the question is, what's my Kb value? Well, my Kb for this, remember Ka times my Kb equals 1 times 10 to the -14. Well, my Kb, if I look up this equation right here, my Kb equals 5.6 times 10 to the -4. That makes my Ka 1.8 times 10 to the -11. Okay, so 1.8 times 10 to the -11, again, I just looked those values up, is going to be equal to x squared over 0.3 minus x. Okay, x ends up being 2.3 times 10 to the -6th, and remember, that's a Ka value. Okay, so I'm good to go. This is my pH, is going to be the negative log of 2.3 times 10 to the -6, and so my pH ends up being 5.6. Okay, pretty straightforward. Now, that's just going to be some of the calculations of those salts along the way. What we did is we got rid of the anion with there and then looked at, okay, what's this leftover cation going to be doing? In this case, it's going to be losing one of the hydrogens off there, creating a hydrogen ion, okay? They can go either way. If both ions can contribute to acidity or the base acidity, how would you determine if the solution is acidic or basic? Well, keep in mind what I showed in the beginning of section 1. If I have more of my acids than my bases, then I'm going to have a low pH and it's going to be acidic. If my bases outweigh my acids, it's going to be basic. Or they could end up being equal to one another, and that would then be neutral. So we can practice this up by taking a look at a couple of examples. We've got this ammonium acetate, and so what's going to happen is, if I were to dissociate this, my ammonium acetate is going to split up into ammonium and my acetate, C2H3O2, with a negative charge. So what could happen is this could lose one of the hydrogen ions, or this could gain one of the hydrogen ions, okay? And so the question is, who's a stronger force? Well, if I take a look at my NH4 value, I see that my Ka for this is 5.6 times 10 to the negative 10. And if I look at my acetate, C2H3O2, now again, we're trying to get a balancing act with my Kas and Kbs. So if I look up my value on this one, my Kb value is going to be 5.6 times 10 to the negative 10. What just happened? My Ka equals my Kb. And so what that ends up being is neutral, okay? Don't look up Kas for both. We have to flip them, and sometimes we have to put that in and multiply to solve for the other thing. So just watch out for those values along the way. And this is what I mean by substituting in the values. Let's take a look at another one. We have ammonium cyanide, okay? Ammonium cyanide is going to dissociate, and as it dissociates, the ammonium cyanide is going to dissociate into the ammonium ion and the cyanide ion, okay? And so this guy could go donate and this guy would receive. And the question is, when I look this up, remember my ammonium, we just saw that one in action. The Ka was equal to 5.6 times 10 to the negative 10. Okay, now if I take a look at that one, I want to know my Kb for my cyanide. Unfortunately, I can't just look that one up. I do know my Ka value of cyanide. My Ka value ended up being 6.2 times 10 to the negative 10. Okay, but I want to know my Kb. Okay, and the reason is if I look up this value, this is already given, so I want to know the Kb of my cyanide. Well, remember, if I've given one of those things, the product of those two, when I multiply them, will total 1 times 10 to the negative 14. So my Kb value, if I just divide both sides by the 6.2, my Kb ends up being 1.6 times 10 to the negative 5. Okay, so what do I see? I see that my Kb is actually, in this case, larger than my Ka. Okay, my Kb is larger than that, so therefore this is going to be a basic solution. Okay, really straightforward with these. I don't think you're going to have any problems with there. Just know how to plug values in and use your charts. Okay, that's it for this section. Good luck.